Hello everyone, welcome back to the another session in design and analysis of algorithms. The topic is dynamic programming. This topic you'll find in third unit, topic number 7. So in this video, we'll be going to cover these three things, which are what is dynamic programming, that means optimality principle of dynamic programming, and the differences between greedy method and dynamic programming. And this is very important question from third unit as far as OU external paper, end semester examination paper is considered. And there are two different approaches in dynamic programming, which is recursive and iterative. So mostly which approach we used to follow in dynamic programming, that part we'll discuss in this video. Now the basic definition of dynamic programming is, dynamic programming is an algorithm design method. So the same way we were discussed for greedy method is also algorithm design method. Dynamic programming is also algorithm design method or algorithm technique to apply on computational problems to get the best solution. So the uniqueness of this dynamic programming is what? This method can be used when the solution to a problem can be viewed as the result of a sequence of decisions. This is what the definition of dynamic programming, and keep this term in the mind, sequence of decisions. Now, what is optimality principle? Optimality principle is what? Let us assume that we have a problem P. For every problem there will be many solutions, and these solutions we used to call with the name of feasible solutions. So among all the sequence of decisions, we will pick up one result as the best result or the best solution. From all these one, we will take only one, that is yes, I am representing. So S1 is what? It is one of the solution. S2 is one of the solution. S3 is one of the solution, and there may be many solutions for one problem. Out of all this, when you have a sequence of decisions or sequence of solutions, you will choose one solution among it, which is the best solution or which is the optimum solution. So the sequence of decisions are called as what? Dynamic programming. Now, what is optimality principle? Optimality principle is what? The principle of optimality states that an optimal sequence of decisions has the property that whatever the initial state and decision are, the remaining decisions must constitute an optimal decision sequence with regard to the state resulting from the first decision. This is what optimality principle of dynamic programming. Now we'll see about differences in between greedy method and dynamic programming method. Both are to solve optimization problems. What do you mean by optimization problem? Optimization problems are those which requires either minimum result or maximum result. This is what the mean of optimization problem. And both are for same purpose. Maybe the different strategies we have, but both are for same purpose. The purpose is what? To get the solutions or to solve the problems, optimization. Both are to solve optimization problems. So this is what the first difference in between greedy method and dynamic programming method. And we are also having the other difference. The second difference of this is what? In greedy method, we will follow predefined procedures to get the optimum solution. Predefined procedure we used to follow. And I'll give an example to understand the same. The example is Kruskal algorithm. You might have remembered from the previous lectures, Kruskal algorithm. So what is Kruskal algorithm? We always select the minimum cost edge which gives the best result. And you can also take the other example, which is shortest path algorithm. In this also, we always select shortest path edge and continue relaxing the vertex. Then we'll get the shortest path from the problem, correct? So in both the techniques, in Kruskal algorithm, in shortest path routing algorithm, in both we have a well-defined procedure to follow, whereas we will not solve the problem to find all feasible solutions, correct? But this is what greedy method. dynamic programming is not that. Dynamic programming is what? We will be try to find all possible solutions. In dynamic programming, what we'll do is we will try to find all possible solutions, then pick up the best solution. This approach is little time consuming compared to greedy method. And for any problem, there may be many solutions which are feasible. So we will try to get the best solution out of it from the sequence of decisions. So mostly dynamic programming problems are solved by using recursive formulas. Recursive formulas. Though we will not use a recursion of programming, but the formulas are recursive. If we want, we can use recursion also, but mostly they are solving using iteration or iterative procedure. So dynamic programming follows principle of optimality, and it says that a problem can be solved by taking sequence of decisions or sequence of feasible solutions to get the optimum solution. So now I can say one difference here, that is greedy method decision is taken one time, that we will do it like this and we'll follow that procedure. Whereas in dynamic programming, every stage we will take a decision. And this is what the difference. And here, as I told you, in dynamic programming, we will be going to solve using recursive approach and iterative approach. But mostly we'll take iterative approach. I'll tell you why, and why only iterative, why not recursive, that also we'll discuss. Now let's see. So we used to write two kind of approaches to follow, which is iterative and recursive. So recursive is what we will be, let us take some example to implement the same, that I am taking some Fibonacci, finding Fibonacci nth term using recursion. So this is my example problem. Now I am going to find the solution using recursive method. So what recursive method will tell is, now I am just taking n value as 5. Assume this. If my n value is 5, then the first condition is what? It is n value is 5. We'll come to here. 5 less than or equal to 1. Condition true. 5 less than or equal to 1. Condition not true. It is false, right? Condition is false. When condition is false, we will come to this statement, and what is here? Fibonacci n minus 2, Fibonacci n minus 1. So naturally we'll begin with what? Fibonacci phi is called from this, and from this we will be going to call Fibonacci phi minus 2, that means Fibonacci 3, and Fibonacci 4, correct? Now let's see here. Fibonacci phi is what? We started with the n value and we will be going to till Fibonacci 0 value. So this approach is called as what? Top down approach. What is recursive approach is also called as top down approach, as I am starting with the Fibonacci phi. If you see the iterative approach naturally we will begins with what? We will take Fibonacci, we'll take some array and we'll take the first value Fibonacci 0 at the index always will be 0, and Fibonacci 1 index always will be 1, correct? If I take some array, then if I point out the indexes, now always Fibonacci 0 at the term 0, first term 0, 0 plus 1 it will be 1, 1 plus 1 it is 2, 2 plus 1 it is 3, 3 plus 2 it is 5. So this is what Fibonacci series, right? So as far as iterative approach is considered, what we'll be going to do is, we'll be taking Fibonacci 0 at the term as constant, Fibonacci 1 term as constant, and from the Fibonacci 2 we'll run a for loop, that is I is equal to 2, I less than or equal to n, I plus plus. So in this, what we will be doing, we were starting with the 2, right? That means to find out this phi value, we will be going from bottom up approach, correct? So iterative is what? Bottom up approach, and this is iterative is also called as tabulation method. So tabulation method is what? We will make some table and we will store, we'll update the value of Fibonacci here in this. And this is recursive is what? Memorization method. In memorization method, we will be going to take recursive tree, and here Fibonacci 5 function is being called. So when you are calling this function, you will be coming to implement these two values, right, to find these two values. As these two values are not known in the function, again we'll be going to call, right? Again what we'll be going to call? Fibonacci 3 minus 2 is 1 and 3 minus 1 is Fibonacci 2. And in Fibonacci 4, it will again Fibonacci 2 and Fibonacci 3. And look at this, Fibonacci 3 value is going to be get here and here also. That means function is called many times. So when you are doing the same job recursively or again and again, the time complexity, obviously it will be more. So you can watch recurrence relation videos so that you can understand what I am teaching here. So if you see the time complexity of this, T of n is equal to 2Tn minus 1 plus 1. Now if you calculate this recurrence relation, you will get the value big O of 2 power n, exponential value. That means it is what? The upper bound value. My n value is here. So my result solution is what? 2 power n. This is what? The upper bound value and the maximum time complexity. It takes maximum time to get the solution. So I wanted to reduce this 2 power n. So what I am going to do is, I am going to take some array. So in this array, I am updating the value once it is found. I am not going to call the function recursively. If here I am getting the value of Fibonacci 3, I am just updating the Fibonacci 3 value with the x, whichever value I found, that value I am updating in the array. So when the function is again called here, I am not going to implement the function because already the value is updated in the array. With this, I am going to reduce the time complexity. So this is what? A recursive approach and iterative approach. Iterative approach basically will use in dynamic programming. Iterative approach will not use that much recursive approach, but anything is okay. Iterative approach, recursive approach, implementation part, anything you can take, but preferably we'll take iterative approach. So this is about optimality principle and just introduction to dynamic programming. So as far as the syllabus is considered, we are going to discuss about dynamic programming problems, which are all pairs shortest path problem, and even we do have knapsack problem. So all these problems we'll be going to cover in the next videos. Thank you all.